This is the Section 6.2 and 6.3 math cast. Together they contain 7 lessons. Students develop the binomial probability distribution formula by examining the results of repeated trials of a discrete random variable. Then use calculator binomial probability density function and cumulative density function to explore a scenario involving tree mortality in a forest. Students will examine and describe the center, shape, and spread of different binomial probability density functions. Use their knowledge of mean and variance for any discrete probability distribution to derive formulas for the mean and variance of binomial probability density functions. Sample from binomial distributions with various parameters p and n to determine reasonable boundaries for normal approximations. Then, after a brief introduction to the geometric distribution, work a variety of problems that require identifying the situation as normal, binomial, or geometric, and then solving. In Lesson 6.2.1, Mr. Knowlson is back from Problem 533 with another impossible chemistry quiz. This is bad for chemistry, but good for demonstrating consecutive independent events and the power of the binomial distribution. Students start with a systematic list of all possible Mr. Knowlson test results and compute outcomes. Looking for patterns. Assuming all answers are random and therefore independent. The probabilities are made into a table and then into a discrete probability distribution. Students can then begin generalizing, finding number of ways without counting from the table or even having to make a table to derive the binomial probability formula. Lesson 6.2.1 does include a resource page that you can copy or project to the class. Combinations appear again from Lesson 3.2.2 in problems 634 through 636. This chapter does not focus specifically on counting principles and assumes that the students have some prior experience with combinations and permutations. In Lesson 6.2.2, the tree mortality theme is begun. Students experience the binomial formula's limits when calculating using large values of n and k, such as 100 for n and 30 for k, or 1000 for n and 150 for k. But this tension is soon relieved by the discovery of readily available calculator functions. Students perform an investigation to learn the value of the binomial cumulative density function. You will want to be comfortable using binomial PDF and CDF functions on your class's chosen calculator. In Lesson 6.2.3, the tree mortality theme is extended and used to exercise binomial PDF and CDF calculator functions. The strict requirements for the binomial setting are formalized in a Math Notes box. Again, you'll want to be comfortable performing binomial PDF and CDF calculations on your class's calculator of choice, including the complement rule and greater than results. Be sure that your students are including correct probability notation with each calculation and answer. Lesson 6.2.4 begins with a very simple one-trial probability distribution where y represents the number of successes. The general formulas for the mean and variance of any discrete probability distribution are applied. The mean of the one-trial distribution simplifies to just p. The variance of the one-trial distribution simplifies to p times 1 minus p. Using the rules for combining distributions, the one-trial formulas can be extended to any number of trials n to get the binomial formulas for mean and variance. This lesson includes the use of the Binomial Distribution Explorer E tool, so you want to be familiar with its use. Students will be making generalizations about binomial distribution shapes, but no formalization is required until the next lesson. The binomial probability density function formula is given in a math notes box. However, expected value and standard deviation are formalized in Lesson 625. In Lesson 625, again, the students will be using the Binomial Distribution Explorer e-tool to observe the shape of various binomial distributions for various combinations of n and p. Using intuition, they will find combinations for which the binomial distribution looks like the normal distribution, is close to the normal distribution, or is obviously skewed. As the pairs of n and p are plotted on a scatter plot, students will see how the conditions np is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10 form graphical boundaries that reasonably separate these categories visually. The data can be copied over to Desmos as tables for displaying along with the two functions, or this activity can be done with sticky dots and the functions graphed by hand. The concept of a continuity correction factor is introduced in problem 677. Continuity correction is not a required topic, but this does offer a very practical response to the unreasonableness of some approximations. The normal approximation of the binomial is an explicit condition for the sampling distributions of proportion used in the coming chapters on inference. In Lesson 631, the tree mortality theme is continued and used to introduce the geometric distribution. The lesson begins with a short review of a geometric sequence, and you may want to review this personally before the lesson. In Lesson 632, the students experience a variety of problems from a variety of contexts. Reading through a problem and determining the appropriate setting, binomial, geometric, normal, etc., and applying the appropriate techniques is a significant skill practiced here. Again, the problem generator is an excellent source for these kinds of mixed review problems. This is the end of Chapter 6 and generally the end of the first semester. Semester 2 chapters, 7 through 13, focus on inferential statistics.